Hello, everyone. Welcome to this talk on running services on Yarn. This talk will actually kind of go into some of the technical changes and the kind of features that are required to run services in Yarn and what has the community been working on, and go into a little bit of depth about what are the kind of problems that we kind of encountered when we initially started working on some of this stuff. A little bit about myself. My name is Varun Vasudev. I've been working on Hadoop for about 3 years now, since Jan 2014. I'm a committer and a PMC member of the Apache Hadoop project, working at Hortonworks. That's my email address. In case anyone has any questions or would like to reach out about stuff they want to discuss offline, please feel free to send me an email. Okay. Quick introduction to Apache Hadoop Yarn for those of you who are kind of not aware or just need to get to speed on what it's doing. We essentially Yarn, we like to call the architectural center of the big data world. It's got pretty good enterprise adoption. We see a lot of customers go out there running Yarn clusters. Secure mode is kind of pretty much the norm now. Very few of our customers seriously run Hadoop in non-secure mode, which means setting up your Kerberos, your KDC, key tabs and stuff, and having authenticated users run jobs. We also see multi-tenancy, again, is one of those things that Yarn promised, and we see it used heavily, especially things like user-to-queue mapping, where you automatically map a user to this queue and manage resources across multiple orgs in this, all using resources on the same cluster. The other piece that's kind of really, this thing that's kind of started emerging is this need for SLAs to be hit. And by what I mean by that is people are just running the same kind of ETL workflows, for example, every day, and they want those ETL workflows to finish on time because they have an Uzi job or somebody's sitting and monitoring and waiting for the result of this thing to finish, and they really don't like unexpected or overflow of this thing. So people would rather have your service running at the same amount of time every day than have it spike up and down in terms of its running time. The reason I kind of just point this out is because one of the most common questions we always get in the Yarn community is, hey, if a machine has spare memory or spare resources, why don't you give it to the container and so help it run faster? Well, what happens is the expectation of the user starts changing, and then they get very upset because the next day there's contention on the machine and your container doesn't get run fast. So, there's also a diversity of workloads. Yarn traditionally has been used primarily for batch and some real-time workloads, but not really for too much on the services side. The real-time workloads, the services like Storm and HBase would typically be done using node labels and partitioning. But what we kind of, with LLAP, what's really happening is getting really a first big services workload running on Yarn. For those of you who don't know what LLAP is, I'll just kind of briefly touch upon it. But it's a part of Hive to essentially help you run sub-second queries. Quick kind of distribution of, picture of how the Yarn typical Hadoop architecture is. So at the bottom you have HDFS there, which is your distributed file system containing all your data. On top of it you have Yarn, which helps you manage resources in the cluster. And on top of that you have applications running. Now this is like, I would say about, this diagram has been used for, I would say, for the past 3 or 4 years by pretty much anyone who does a thing on big data, just because it's been pretty representative for quite a while on how big data workloads and big data clusters would look. It was just a very, very correctly representative diagram. But we've seen, especially I think in the last year or so, there's been kind of massive changes in what we expect to this thing. The first one is at the bottom layer. For a long time, Hadoop was primarily run on enterprise-grade on-premise hardware. We're seeing a big change in that. A lot of customers and people are very interested in running Hadoop on the cloud, either a public cloud like Amazon AWS or Google Compute or Microsoft Azure, or on their own private clouds. Companies are invested in private cloud solutions, and they want to run Hadoop on these cloud systems, sorry. Then from the expectation from the Yarn side also has actually kind of changed a bit. There's much more requirements to handle things like service discovery, like in LLAP's case. Governance and security is becoming even more kind of, I would say, becoming more and more advanced and mature. Things like Ranger are plugging in directly into Yarn now, so you can control policies at like a Ranger level and then just get reflected in Yarn, queue access policies and things like that. So a lot of kind of requirements coming around, how to kind of get Yarn to behave in a secure manner and be able to control that via Ranger. And on the top, a lot of new workloads. I think TensorFlow has been mentioned quite a bit in this conference, and a colleague of ours actually put up a blog the other day on how to run TensorFlow on Yarn. Those new workloads, which essentially require more of a services kind of kind of support are becoming much, much more popular. On the right there is an example of an assembly which we also adding support for, where essentially Yarn can wire up components for you and kind of help you connect them and discover, and they can all discover each other, and you can essentially treat all these components as one unit instead of dealing with them individually and trying to find each one, etc. So coming back to why the services workloads are becoming more popular. The biggest, I mean, we've always had Hive and HBase running. Hive servers would run by themselves, but with LLAP, the services requirements from Yarn became kind of a lot more. So if you attended Sanjay's talk, or if anyone's kind of aware of, not aware of LLAP, LLAP stands for Live Long in Process, and it's essentially the Hive story for sub-second queries. And LLAP, the way it works is it runs these massive caches of query fragments. And they needed essentially a simple solution where they could get a bunch of resources on the machines, and the container bring up or down. They didn't kind of want to get into the resource management piece of it. They just wanted to handle the caching piece. And so they started running LLAP on Slido on Yarn. This is actually now, I think in the last HDP or in the release will become production. But this was like our first really massive production services use case. But even in the Hadoop 3, as it comes along, we're kind of finding more and more reasons to support services on Yarn. Now, I just want to kind of point out that none of these use cases are actually non-big data use cases. It's not like we're bringing external workloads in. They're just use cases that came up and natively out of the way big data is actually moving. The first simple use case is essentially, it still applies to the old batch world. I ran a MapReduce job. I would like to bring up a web server so I can just serve these results to somebody. This was, it's a fairly simple, straightforward use case. And the second one, for example, is in the Hadoop 3 world, you have a new Yarn UI. That new Yarn UI is supposed to run as its own container. It uses REST APIs to contact the RM and to get display data. Now, the reason it was written as that is we really wanted to move the UI out of the RM. So it can run its own containers. You can do things like load balancing. You don't have to worry about DOSing the RM just because everyone's trying to access the UI. Now somebody has to manage these UI containers. They have to be brought up. They should be able to be discovered. If they go down, somebody has to restart them. Just a classic services use case. The ATS v2 has a slightly more complicated use case. The ATS v2 is the application timeline server. And in the Hadoop 3 world, we're going to start writing a lot more data into it. And because it's such a fairly big and complex piece, it also offers an ATS reader that will ship along with the ATS v2. And this reader has a bunch of business logic on how to answer a query, how to do pagination and things like that. And this needs to be run a container as well. Again, the same problem arises. If the reader goes down, then ATS is essentially inaccessible. And so you really want to add support for this thing. And I would say the most kind of complex service you could think of in the existing thing is Shuffle. For those of you who are kind of unaware of how Shuffle works today, Shuffle today actually runs in the node manager on the machine. And that is actually, from a Yarn developer's perspective, it causes a lot of heartache for us. Primarily because Shuffle runs without any constraints. And if it goes down, it essentially takes the node manager down with it. Now, traditionally, we would only run one version of Shuffle. That is MR's MapReduce's Shuffle. Today, Thales has its own version of Shuffle, MapReduce has its own version of Shuffle, Spark has its own version of Shuffle, and all three of them are loaded into the node manager and run as this thing. They can all go crazy in terms of resource requirements. There's no kind of constraints on them. There's no accounting of who's using how much resources. The XMX for the node manager, you better hope that the Shuffle services aren't doing something crazy because it just bring the node manager down, and what's going to happen then? So it's always been like a pipe dream of the community to pull Shuffle out completely and run as a standalone service. But if you run Shuffle as a standalone service, then you have to solve all these problems of how do the existing applications continue to run without having to rethink all these issues. And so I think that's like the most complex use case of a big data service that needs to run on Yarn. But hopefully one day we'll get there sooner rather than later. So a quick kind of overview of the current about a year ago, this was the application lifecycle on Yarn. You have a node manager that's running on a node, and a resource manager that's the active one. The node manager heartbeats its resources to the resource manager, which realizes there's an application waiting to launch, and so it tells the node manager to launch an AM. The node manager will launch the AM using a container executor. You have default container executor, Linux container executor, Windows, whichever one is being configured to set up, and it launches the AM process. This AM process then asks the resource manager for resources. I want a container. The RM will give it back the containers that it requested, and then those containers get launched as well using the same container executor. Now these processes, once they're done, all the resources are reclaimed and anything that they wrote on disk gets wiped out. At that point, the AM, once it's feels the work is done, will write some kind of history data either into the ATS using LevelDB or job history server in terms of MapReduce world. And once it's done, the node will kick off log aggregation to collect all the logs and put them on DFS for you to kind of look at later. So if you look at the lifecycle, it's really designed well for batch jobs. The assumption is typically the batch jobs will be running in the orders of days, hours and days, maybe not we really don't expect it to run for more than that. The next basic assumption is that these jobs are running using frameworks that are Yarn aware, like MR, Thais, Spark are all aware of the fact that they're running on Yarn and have written logic to kind of handle these use cases and have adjusted themselves to kind of to Yarn sensibilities and the way of right way of doing things on Yarn. Container failure is bad, but it's not like catastrophic. Really don't kind of, if one mapper goes down, we'll just find somewhere else to run it and hope that it works there. But it's not going to be the end of the world. The job will run in reasonable amounts of time. And the frameworks themselves have written logic to handle container loss for however reason, whatever thing they want. And then finally, something like an Uzi is aware of the fact, again, that it's running on Yarn, so it knows that there's something called an application ID. This application ID will be generated and is unique within the cluster, so I can use this application ID to chain jobs or pipeline jobs. And finally, and this is, I think, one of the interesting ones, is debugging is an offline event, right? Typically, when the job fails, you kind of go out to it after the job has failed, you'll fetch the logs and access it, but while the job is running, there's very little debugging that tends to happen unless you're actively trying to look for a problem. None of this carries over very well into the services world. Firstly, services tend to be run for very, very long periods of time. You really don't have a limit on how long a service should run. You want it to run as long as possible until either you decide to shut it down or you have some reason to upgrade it or whatever it is. But there shouldn't be like a inherent platform limitation on how long a service should be run. Next one, obviously, services may or may not be aware of Yarn. For the simple use cases, even the Yarn UI, which is just a simple Ember application that's running, you really can't force it to go figure out the intricacies of how Yarn works and then just to get it run on Yarn. It's just not a reasonable thing to do. Container loss is a really big problem. A good example is something like Zookeeper. Or something. If a Zookeeper server goes down, that's a really bad event. You really want to bring that server back up as quickly as possible. You can't wait and take your time, try to figure out what went on there. Services would like to discover other services. Again, you can't expect folks to know what an application ID is and try to use that to discover other services. You really want a better service discovery mechanism, and so you have to figure that out. And finally, debugging is an online event. Something is running slow, I want to be able to immediately log in and figure out what the hell's going on. Why is it running slow? Where did it come from? What is the root cause, and try to address it immediately. So these are kind of like the bunch of the issues that started popping up when we started looking seriously at these services workloads and what are the kind of things we have to solve. And so what are the community started fixing these in order and try to figure out what we should be doing. So the first one is, so these are a list of issues that come with enabling service. You have to fix an AM, you have to fix service discovery, you have to fix container lifecycle, scheduler changes. You need to have a UI to kind of at least help you do stuff easier and better. How do you handle application upgrades? How do you handle log collection, et cetera, in the services world? So this is the first most kind of critical one, right? You now need an AM to manage services. Nobody's going to write their AM, a new AM just to run on Yarn. First of all, AMs are hard to write. It's a fairly complex piece of work. It's not really easy to get it right. And so as you write these AMs, and if you're writing an AM for different services, the chances are most of the logic is the same. You're doing things like flexing up or flexing down of containers, recovering running containers. It's not really stuff that you're, across many services, that a lot of the common core logic will be the same. The other problem with writing an AM is you also have to now keep up with the Yarn community. Well, what if Yarn adds a new API or new change or some new feature, you have to go follow it up. If something changes in behavior, you have to follow it up. Really, again, not very practical to expect individual services to go and start writing this stuff. So what we kind of did in the Yarn community is add a native framework for managing services. And the Jira is 5079, if anyone, Yarn 5079, anyone wants to follow it. Essentially now we will ship an AM as part of the Apache Hadoop distribution, just like how we ship MR and we ship distributed cell, which meant primarily for running services on Yarn. The AM that's shipped is derived from the Apache Slider project. The Apache Slider project, for those of you who don't know, is an Apache project that, and the reason it's called Slider is interesting, is because it lets you slide applications onto Yarn. It provides a generic AM, just primarily to run services. And it has this nice API and REST API to and a spec file where you can go say what are the resources you need and stuff. And they have done a lot of the work for running services on Yarn. So we've taken that AM, we essentially merged it. There's a branch where it's part of Yarn, and we started making modifications to it to make it run better. For example, one of the things that Slider requires is a Python agent to run on the node manager site, which kind of collects information about how the service is running. We can't enforce a Python requirement, so a lot of the work that the agent done has now been moved into the node manager and natively add support for things like that. We also have a new, the AM in the slide AM also has support for things like port scheduling and things like flexing up and flexing down of containers. And so all these good bits that Slider had kind of solved, we just get for free by getting the AM over. And a big thanks to the Apache Slider community for actually contributing that AM back to the Yarn project. The other benefit of this AM, again, is now the Yarn developers themselves are going to start maintaining it, so you don't kind of need to worry about stuff going out of tune, out of date, because as you fix the APIs, you can get the right behaviors sorted out as well. We also have new REST APIs to launch services and native to Yarn itself. This is actually an example of a fairly simple JSON that, at least straightforward, at least I think it's simple, to launch a service. So going from the top down, the first one is the name of the service. It's just I was trying to run a Druid on Yarn cluster. The resources it need, I just wanted everything to have the same amount of resources, so that's pretty straightforward. The components, I had a Docker image, so everything that was just baked into that image, I didn't really have to kind of separate out the components, but you could actually have multiple components as part of this services definition. The artifact ID, again, like I said, I was using a Docker image, so it was I just need the Docker image ID and it would just pull the images. Some configuration stuff, environmental properties that you want to inject into the image, so when we launch, you have your environment set up correctly, the number of containers, a launch command, and the queue. Now, this is a pretty simple example. It's not fairly too complicated. If you really wanted, for example, you could separate out those Zookeeper servers into their own component as well, and then Yarn would spin up the Zookeeper servers. You could specify order of bringing up, so you would first bring up the Zookeeper application, then bring up the Druid application, and then kind of link the two using service discovery. You could do things like expose a DNS name that you would like to use for access for service discovery. But this is essentially how we have started off with, supporting services in a first-class manner on Yarn. So we've got the AM to run the services. Now we need to solve the discovery problem. Again, application IDs clearly don't work. Neither do container IDs. Now, for example, I would like to talk to a specific HBase region server for some reason. Like, how do I discover a region server? And containers come up and go down, so if a region server is restarted on another machine, I still want to be able to find that machine using the generic services that are provided by Yarn itself. So Yarn 4757 adds discovery support for discovery and long-running services, and the solution is pretty straightforward. It's DNS. Right? DNS is very well understood for discovery. Most people have no problems understanding how it works. And the way this works is there is a piece of Hadoop which is a little not as well known called the registry server, which has been shipped as part of Hadoop, I think, for about 1.5 years now. And that actually has a mapping, a running mapping of what's running in the cluster. And it is based off Zookeeper. And what we essentially have done is add a mapping from the registry server to a DNS server. Now, the DNS server that we have in the Yarn branch currently is an experimental one. It's only meant for testing. Please do not run in production. But it's based off DNS Java in case anyone wants to take a look. And what it does is essentially give you a running DNS server for services. We do need to add support for dynamic DNS so that we can plug into existing DNS solutions in enterprises, and that is high on our to-do list. And it should get completed reasonably soon. At least it should be, we are very confident it will be part of the Hadoop 3 release, the GA release. So this is how it kind of ends up working. So a user submits a request for a service to the resource manager, which launches the AM, and updates the registry service. Now the registry service essentially knows that an AM has been launched. It knows the user has launched the AM as well. If you have specified a specific kind of name for or discovery pattern name pattern that you would like, it goes and updates that. The application manager asks for the node containers, you get the containers back. The application manager then updates the registry service as well. Now the registry service, like I mentioned before, is backed by Zookeeper. And the DNS server is essentially just watching Zookeeper. It has watchers on the node, the right paths. And so it is just really reflecting what the state of the thing as reported by the registry server. So when the application manager updates the registry server, it actually says this container is running with this IP, and this is the host name that was requested, and that will just essentially just get reflected back into the DNS server immediately. And then the user can query the DNS server to get this thing. So this is how we essentially do a lot of the wire up of individual components that are tied together, just using host names and this thing. We also generate a bunch of kind of host names for every container anyway, just so you can discover individual containers, but it's not, most users essentially really want to specify their own host names and their own patterns, and we use those. Okay, so we solve the problem of, at least we have some solution towards the service discovery. Now we get to the container lifecycle. Again, the traditional batch kind of node manager, what we would do, the first thing when a container process exits is we would delete all its local data. This is essentially any local state gets cleaned up. Let's say the node manager really need to run, the application manager need to lead the container to run on a specific node. It has to go back to the RM, request for that container again. But by the time the heartbeat cycle and scheduling cycles again happens, it does take some time for it to get back to that node, and then it has to actually download all the resources required for that container all over again. Not very optimal. So in Yarn 4725, we actually had support for first-class retries on the container itself. Now, you might think, what's the big deal here? But a lot of folks actually, and this is a fairly common thing, don't actually, for example, know how much memory to allocate for a container. And so there's a lot of trial and error here. You'll be surprised the number of containers that get killed simply because their memory requirements are not correctly specified. If you have to download a bunch of heavy resources, for example, a lot of folks who are doing ML stuff will want to download a gig or 2 gigs or 3 gigs worth of model data. To re-download all those resources simply because your initial container was sized wrongly or ran out of memory due to some unexpected this thing, it's a fairly heavy price to pay, on heavily loaded clusters especially. And so we have support for first-class container retries. So in this case, on process exit, we actually don't clean up. AM can actually specify a retry policy. And these retry policies can be things like, always retry on specific error codes. You can specify a delay between retries so that you don't kind of spin in a retry loop for too long, and things like that. And just to kind of visualize it, you have a node manager with 3 disks. You have HDFS running over there. You have some application data that you downloaded. You launch the container process, and the container wrote some container data to the disk. Now, let's say due to an you kind of end up killing the container process, or there was just some error in some processing, and you end up with something that caused the container process to go away. We actually keep that data on the same disks. We'll relaunch the container process with that same disk provided, so that your container doesn't need to kind of figure out which of the disks your original data was on. As far as possible, we'll try to give you the same environment, presuming the disk hasn't gone bad or something has happened in the time the container was running, get you back onto the same state, and then when the container exits cleanly, that's when we'll do the actual cleanup. The most kind of simple example I can give where something like this is really kind of we found very useful is some Zookeeper. A lot of folks want to run just a simple 3-node Zookeeper setup, and if you keep cleaning up the data without just because of something runs out of memory or something, it's just a pain for everybody. So scheduler improvements. This is been just a really, really important thing now. Again, with the services use cases, we found a lot of affinity and anti-affinity requirements becoming harder and more and more important to get right. The most important easiest example I can give is, in Zookeeper or HBase, you don't want 2 HBase region servers running together. You don't want 2 Zookeeper ZK nodes on the same schedule on the same machine. You really want to spread them out. And in case of anti-affinity, and that's an anti-affinity case. In case of affinity, you might want to run a Spark job close to your region server. You might want to run a Storm workers together because you want this thing. We have the slider AIM actually also has already some support for affinity, anti-affinity at a container level, but not at an application level. And the RM can actually do much better job of some of this stuff because of it has a global state knowledge. The Jira again is Yarn 5907. Now this is an example of where you need anti-affinity. You want to spread out the HBase region servers. Kind of just something to kind of note on how affinity, anti-affinity are a little kind of sometimes hard to get right. These are actually, the notion of a fault zone is actually very, very, you really want to be able to fall back. You want to be able to say, ideally, I don't want two region servers maybe in the same, on the side, definitely don't want the same node. Maybe I want to spread them across 2 racks. Maybe I want them on the same, this thing. So depending on, you really want to be able to have fallback policies to be able to schedule these containers, right? It becomes more important, say, for example, in Storm, you want the containers as close to each other. If you can't get them on the same node, at least try to get them for me in the same rack. And so these placement sets become a bit more important and a bit more tricky. And so sometimes there's soft and hard affinity, anti-affinity requirements with fallback policies that you need to add support for. This is the new Yarn UI. Okay, so if any of you have used the existing Yarn UI, my apologies. It's just really, really bad. So some time ago in Yarn 3368, an effort was started off to run a better version of the Yarn UI, something that's actually useful and can be used by most people. This is a screenshot of that. Yarn 3368 is the parent Jira. It uses, like I mentioned, REST APIs. But one of the things we did in this thing in the new Yarn UI, and it has like lots of really useful information when you're trying to debug containers, is we actually had separate support for a long-running services section. So you can just go here to figure out where all your long-running services are running. If you actually click into the individual applications, it'll actually tell you the exact nodes on which the containers are running, how much pressure is there on each node, how many other containers are running on those nodes, so you can kind of figure out what is going on. It'll also give you a list of the IPs. It'll tell you what the host names mapping are. And it's just a very, very useful this thing. This is about to get committed. I think this is an internal screenshot, so it may not be committed in the community yet, but it's going to go in very soon. Much, much more useful for debugging than the current RMUI, which is frankly is something out of the 1990s. This is work that is a little, I would say, not really complete yet. Application upgrades is a little tricky and something we have to kind of get right. When it comes to application upgrades on Yarn, there are 2 things we need to kind of think about. One is the individual container upgrade itself, and then there is the application itself. The difference between them is a container upgrade is something like a rolling upgrade for an existing running application. You want to upgrade one container, see if it's working fine. If it's working fine, move on to the next one, et cetera, et cetera. The application upgrade is you want to upgrade the slider AM itself because the newer AM has some versions or some things that you want that you need, some new feature. And we do have support for container upgrades and rollbacks, the Yarn 4726 actually thing, but we don't have support for in-place application upgrades. 4726 is not even in the sense we don't even have support for things like a rolling upgrade. We actually do only have support for a container upgrade. So you can go and say, change this container's resources and restart it, and that we can do, but we don't have that logic yet to say do it one by one with a gap of say 5 seconds or 10 seconds between each upgrade and then come back to me when everything is done. That support for that is still being built out. Other kind of things that we had to fix, this should not be log rotation, it should be log collection. Today log collection used to run, typically log collection would run at the end of a job. Again, in the services use case, it doesn't really make sense to do log collection at the end of the job. So the non-logs tool actually now provides a list of running containers. You can fetch logs at a container level. You can actually fetch specific files and say, give me this log file. You can even do things like give me the last, I don't think we have support for lines, but we do have support for bytes. So you can say, give me the last 10K bytes of the log file and stuff like that, just to make things a lot easier to debug. It's just stuff we never really had before. We don't have support for container monitoring. Again, services would like a way to do a TCP or HTTP health check. That's stuff that's being planned and something we have to develop. And once we get that, we can kind of at least do, the node manager itself can do container restarts if a health check fails enough number of times and stuff like that. And okay, in conclusion, the services workloads are becoming more and more popular in Yarn. And I think we have the, as a developer, I can say we have the fundamental pieces in place. There are a few more to go. We aim to have all of them ready for the Hadoop 3 launch. That's our plan internally, at least, to get it out there. In case you have more questions, you want to discuss some of this stuff further, I will be at the BOF session tomorrow. And you can feel free to come up and kind of, if you want to contribute to or feel something is missing, I think please feel free to bring it up there. And that's the end of my talk. Any questions? Yes?
I don't
Oh, it's just, we find one of the common things is to run HBase on Yarn. Just because you can run multiple versions of HBase. So if you're an organization that's running HBase and you're running one HBase, everyone is hitting the same HBase for test, production, whatever, right? You want to be able to separate out the workloads. You want to try out a new version of HBase. You want to try out stuff like that. So in those cases, you want the ability to spin up one small HBase cluster, maybe of 5 nodes, just to basically do simple functionality checks and stuff like that. That's an example of where you would want on HBase on Yarn, just to kind of understand how some of this stuff works. You also get more resource management. Typically, most people run HBase on its own nodes. It's just an example. If the HBase is not being heavily utilized, but those nodes are essentially not being utilized at all, so you get better resource management, more efficiency, cluster utilization goes up. Those are the kind of problems you end up solving. It's just a general this thing. Yeah, it is not like, I'm not going to say that, you should run HBase on Yarn. Absolutely not. That's just, it's just an example of why somebody would want. Yeah, it's just this thing. Yes? Sorry, I can't. I think the Hadoop community itself doesn't plan to ship anything by default. Our solution will be essentially, I think what we'll do is ship example spec files so that you can use to this thing. I just called out LLAP because it's an existing, it's a use case that we currently have. But I would assume that most of the things would be just the spec files. I don't think there's notion of an explicit support thing that's planned as yet, at least not that I'm aware of. Just the reason I kind of say that is, when you say we support something, that means we have the tools to debug failure, we have the tools to kind of understand how to improve performance, et cetera, et cetera. The Hadoop community itself, at least the Hadoop project, may not kind of be in a place to provide that kind of I would say expertise, right? So LLAP, for example, runs on Yarn, but it's the LLAP developers who kind of understand how to debug LLAP slowness. What they need from Yarn is essentially low-level tools to tell you where LLAP is running. But from that point, they essentially they use their own the Yarn logs tool to fetch the logs and debug stuff. So when somebody says, we support, when somebody says I run LLAP on Yarn, really the LLAP guys do the debugging, not the Yarn guys most of the time. Right? So we'll provide tools for you to inspect a service. But for example, we won't know how to wire up your service. We don't know what the affinity, anti-affinity requirements are. So the ideal hope is that you'll have these spec files which are reasonably straightforward, and you can just use those spec files to spread out or collapse your containers. And then with the tools, existing tools, you should have enough in place to debug if something goes wrong. Did that make sense? Okay. Anything else? Okay, I guess that's it. Thank you, everyone.